All right. So this is the Bioconductor Developer Forum for May. We have Enis Afgan. Am I pronouncing your name correctly? I should have asked before. I'm sorry.
Yes, but
Enis Afgan presenting on Galaxy and tool wrapping. And we wanted this topic because we think it's really important for interoperability. People are already putting bioconductor tools into Galaxy, and maybe having a better understanding of how Bioconductor could support this at a systemic level would be quite good for us in the long term. So um, I'm excited to hear what Ennis has to say. And with that, I think you can take it away. You should be able to share your screen already, if I remember correctly.
I'll be accompanied with Tyler, a colleague at Hopkins, to sort of we'll tag team this. Tyler has a lot of experience with sort of using Galaxy. I have more experience with operating Galaxy, and so I figured this would be a good team to present this and answer any questions that you guys might have. Um, so, I mean, this is intended as a you know, interactive and back and forth presentation. We really like to, I guess, show the kind of the process and some of the tooling around getting tools, bioconductor packages specifically wrapped as it's called Galaxy Tools. And so we figured we'd do this live show how to do so for one of the bioconductor packages. And then kind of frame it in the bigger scope of Galaxy with how once a tool is integrated, it becomes easier to combine it with other tools, not necessarily even the ones from a bioconductor world. So it's kind of the gist, I guess, the outline, and we'll go through this again. Interrupt at any point. We have some hands-on sections that have some notes for if people want to follow along, or you can just watch us do this on the screen.
Yeah,
And
questions are great. So if at any point people want something, please interrupt.
um, so I guess we kind of wanted to frame it out as why would one want to do this, and I'd love to hear feedback or thoughts that others have on the call. And so, from my interactions with the Bioconductor team, there are thousands of packages that go through a release process that are tested and vetted and all, and of course super popular. Um, but as people start to kind of get into the domain and all, they may still have some challenges with just starting from our syntax to just different focus and lack of familiarity with the command line. And so I think that's where Galaxy can kind of help bridge that gap and bring people and expose them to those proven bioconductor tools. And then secondly, some of the tooling requires both sort of installation and infrastructure to run on, and Galaxy can offer those. So if one has a package that they maintain, they push it up into the Galaxy world. People that want to use it can hopefully, as we'll see today, just rely on the public infrastructure that Galaxy is leveraging to allow people to run analyses, and hence they don't have to install anything or figure things out on their own local system or in their local environment at their institution. So you can think of Galaxy sort of like a distribution platform, and it has this layer of reproducibility. So we'll show you a couple of slides of where people can easily share the results through just the URL, and so this kind of idea becomes really kind of accessible. And then, of course, the workflow integration will wrap up the presentation with an example of a workflow that one can create from ad hoc analysis, for example. And just as a reminder, right? I mean, we have some. I mean, individually, we have a lot of connections with various people in the Bioconductor team. Last year, we held the joint community conference at Cold Spring Harbor. I guess the verdict's out whether we're going to do that again in the future, but if there's interest, but as always, welcome to an open conversation. So like I said, we have a few slides that sort of introduce Galaxy. And most people here are familiar with it, so I'll run through these really quick. If you have questions, just ask. But Galaxy is celebrating 21 years at this point, and it's amassed like a worldwide community between both or all sort of tool integrators and people that want to expose their tools to people using those tools to people relying on it for training. And it's increasingly starting to be used in classroom settings. So it's sort of like a full circle. Globally, there's over 600,000 registered users across various Galaxy instances, which blows my mind. Monthly active, it's somewhere in the 10 to 20,000 users, but like every month we get 5, 6, 7,000 new users registering as well. So the trajectory is positive. Like I said, there's a bunch of Galaxy instances around the world. There are about 100 that are sort of registered. And the reason one would start up a public Galaxy instance is because they have their own set of tools, or they have their own infrastructure they want to expose to their community or their institution. And then there's a handful of these, what we call the usegalaxy.star federation. So these are usegalaxy.org, usegalaxy.eu, .fr, like national Galaxy instances that are intended to be general purpose. So a wide variety of tools, free to use with reasonable quotas, and sort of support that main body of the community users. So this is the US server. It runs on infrastructure across the United States. A lot of it is at Texas Advanced Computing Center. Good chunk of it is at Indiana University, and then kind of sprinkled at some of the other supercomputing centers around the country. And so some of it is just what's accessible, some of it is opportunistic, some of it is based on the requirements of the specific tools. So we can get anything from high memory machines to GPU nodes, and some of those in more limited quantities than others. And so that's one of the selling points for why sort of integrating a package in Galaxy buys you more, because this infrastructure then becomes available to the users of the package without it having to be installed or maintained. So the project takes that on at that point. And so as far as the user interface goes, as I was saying in sort of the first couple of minutes while we were waiting, so traditionally Galaxy has always been known for its web interface that has eventually been also supported through an API, and now increasingly through just natural language and interaction with AI tooling. But that traditional interface, remains the central, the focal point of Galaxy, and still attracts a lot of users, again, especially students and like biologists per se that don't have a lot of expertise with the sort of technical background or technical tooling. So the main panel is, the main UI is divided in these 3 panels. We have the tool panel on the left that gives you access. You can choose the tool, the center workspace that exposes everything from the initial kind of tool form to the results. And then the history panel that tracks your analysis and the steps that you've performed as you progress with your analysis or as a workflow executes. And then you can always go back to any individual step and kind of inspect anything from the parameters used to inputs to being able to rerun it in a straightforward fashion. So this is, just a current version of the interface. You can see the three panels that I just described. And so recently, I guess you could think of it maybe even as the fourth panel of something we added, what was it, about a year ago, called the activity bar. If you're familiar with VS Code, that's where I think the idea originated from. It's sort of different views into the Galaxy interface, whether you want to work with individual tools, whether you want to work with workflows, visualizations. So you kind of change your center layout based on what you selected there. And then as I said, the tool panel. One thing to keep in mind is that every Galaxy has a different tool panel. A tool needs to be installed into Galaxy, and that's something that at this point, only an administrator of a given Galaxy server can do. Users can't yet install tools in this main tool panel. So if a tool is missing, it needs to be installed for usegalaxy.org. That's a pull request, GitHub pull request driven process. So anybody can request a tool to be added. And once approved by the maintainers of that repository or particular Galaxy instance, it's added into the panel. This is the center panel. You see what the tool form looks like, providing the inputs, parameters for a given tool, and then and then in one particular class of tools, I wanted to raise awareness of is the interactive tools. So our studio is the most relevant example probably for this presentation, but there are many others. So these are highly complex applications that have their own interface. And these have been integrated in Galaxy for quite a few years now. And you get the full sort of experience of using a given tool. It runs in a dedicated container and interacts with your Galaxy data. So you can pull data from Galaxy, push data back to Galaxy. But in this case, you have your own RStudio instance. So this particular one is configured with a number of sort of popular Bioconductor packages. So it's built off the base Bioconductor Docker image as an extension. So if anybody has comments and would like to see additional tool or additional packages added in there, just let me know and we can certainly do that. And then the rightmost panel is what I said, the history panel, which has the sort of the log of all your activities. You can inspect the data sets and rerun them and inspect the parameters and such. And then this is the sharing component that I mentioned. So any history or workflow that you created, you can share. You can make it sort of like Google Documents style. Just get a URL. Anybody that has a URL can access it. You can publish it in the library of published artifacts on a given Galaxy server, or you can choose a different user, and then you just paste, send the URL to the given user, and they can continue where you left, where you stopped, I guess. So easy to kind of give others an opportunity to inspect, either outputs or inputs or whatever you're curious about.
I think I should go back one slide. I think the only thing I'd add is that history serves as almost like a lab notebook. So it allows for full reproducibility. So I just mentioned you can inspect the elements and follow what you do. It will keep track of everything that you're doing through Galaxy. So anything you upload, any tool you run, any other step you take, and then within it, it will have all the exact data that was used to run it. So it'll keep track of which machine it was run on, exact command line tools that were run, how it was executed, resource usage. It'll maintain all of that just for accessibility purposes. And then, or sorry, not accessibility, reproducibility purposes. So it'll just always be there to be able to be referenced going forward. And in addition, all of the tools that you can run and that are accessible through the history are versioned. So if you ever run I don't know, a fast QC that's 3 years out of date in the past, that'll still be accessible on Galaxy and someone can rerun that exact analysis for reproducibility purposes. And if they have your history, it will go back to that previous version, not the latest version.
On the point of that versioning, is that the tool's own versions, or do you set a Galaxy version number for when it's imported into the system?
There's two. So whenever we have a Galaxy version number, that's always added. So if there's ever a change in like the tool wrapper side, it gets incremented whenever it's updated. And then if that's also included with like the default tool version itself. So if there's ever an upgrade to the tool, we'll bump that version and then reset the Galaxy version to 0. And then any changes to the Galaxy only side wrapper will bump in version. So if you like look at it's like that top of the gray bar on the slide, or it says like FastQC. It'll have like the 0.74 is the tool version, and then the Galaxy 0, 1, 2, 3 is the Galaxy Bump version. And then still, I believe we're still fully supporting it, but it should be any version that's ever been installed on the instance will be accessible. So you can swap between the tool form from any of the previous, like I think for FastQC it's like 10 or 15 versions now over the 2 decades, but you can swap between all of them. Um, and then whenever someone like makes a change to a tool or pushes it up, for like the CI testing is required to have the version bumps. So that's all managed and it's all for the purpose of being reproducible.
Awesome. Thank you.
You can continue, Tyler. It's also your
Oh yeah, I can keep going ahead. Yeah, so in addition to having the tools pre-installed on these instances, there's also a set of like preloaded data that's often accessible. So there's a significant amount of like reference genomes, annotations, um, for certain tools, if it like you needed like an index or a weird format or something that would take a while, that's often stored as publicly available data on the server, that users can access when they run the tools just for the purposes of lowering data footprint and making things faster and easier for people. This way you don't have to like every time you run something have to re-download like grch38 or whatever else you're doing onto the server. And in addition, there's also within Galaxy something called like a data library, which is like a shared set of data that users can pull into histories and work on. I guess like the most recent example of one that I've been using is there's like a metagenomic soil sequencing project that has long read and short read data from a couple hundred sites across the US. So within that data library is all of the raw sequencing reads after they've been cleaned up a little bit, and then like initial assembly with like meta MDBG, and that's all structured in a traditional file system that's like fully available and can be moved and analyzed within Galaxy. But since it's used in that one centralized spot where it's stored, it never impacts your storage quota or anything. And then in addition, it's usually quite easy to bring your own data into Galaxy. We support everything from like simple drag and drop browser uploads or anything local. There's an upload utility to pull things down from HPCs or anywhere. We have cloud integration with AWS and Google Cloud buckets that you can connect and pull data down directly. And then you can also fetch data from any web server wherever it's stored. So if it's like yeah, anywhere that's easy, like anywhere from like NCBI, anywhere else, it's pretty easy just to do a quick import. That's all done within the client.
and that's something that is conceptually a little bit maybe different in that before you can start working with data, even if it's on your machine and you start up Galaxy locally, you have to import it into Galaxy. So Galaxy needs to sort of own the data or control the data. You can't just say, oh, here's a path on my machine, use that. You still kind of have to go through this ingestion process. Um, so I think we can maybe even skip this sort of FastQ C example because we'll get to it later when we wrap our own tool, just to make sure we don't run over time. But the idea here was just to show what this kind of process looks like interactively. We have some slides here, just filling
I
out
can
the
go
form.
through it super quickly. It's probably useful
Okay.
to do in like a minute. So if you go back one, oh, is this the start? Yeah.
That's it. Yeah, you still see it. The
I was just say it's whenever you select a tool, it will like load the tool form in the center panel. So whenever a user does it, you'll have like a list of drop-down options, and these will map back and translate to different command line arguments. So you'll be able to pull in data from your history, other things that are in there. So you can select things from there, move them in there. You'll have all of your options. And whenever you have everything selected for how you want to do it, you can just hit run tool. And then basically what happened is it will queue up the job, spin it off on to whatever machine's running it. And you'll have new history items populate with what the outputs of that tool will eventually be. And they'll move from like gray while it's being spun up to yellow while it's running, and then eventually green for success or a red for a failure. And then while it's doing stuff, while it's running and after it's finished, you can go and inspect. So like when FastQC finishes, you'll be able to go through and look at like your full, multiple page FastQC report with all of your different fun images and to go through everything. But the point of this just being we'll wrap a tool here in 1 second, but this is kind of like what an end user sees. So this is still all the full command line that's running, and you still get all of your regular reports and things you get. And in this case, it's obviously a very simple command line run for FastQC, but it lets you just be able to run something like this without ever needing to like do anything in a
Yeah.
terminal.
And you see whatever sort of the background components, including the command that was used to run it, and the resources that were consumed. And again, that's all sort of available but hidden. And what Tyler was saying earlier, that if you come back in a year's time and you hit this rerun button, it'll redo using the same version of the tool. And you only get the same output. Yeah, and that's the output. Again, this is not, I mean, the cool thing here is that it's like in anybody, right? You just go to usegalaxy.org, you can do the same thing.
No.
All right, well, that part. This would be now, if you add another tool on top of that, of course, it'll build your history out as you carry on. And so this is the part where things get maybe a little more sort of relevant, interesting to those that are interested in adding their own tools or packages as to what actually happens behind the scenes. So we saw the tool form for FastQC. It looked like many other forms on the web, just integrated with Galaxy in terms of being able to click the data sets, but also exposing various inputs and parameters that a tool supplied. So how does Galaxy know what that is? That happens through what's called a Galaxy wrapper, which is an XML file that captures. Nick, you were asking about the version, right? It starts off by having like a tool tag that specifies the basics of a tool. It specifies what requirements, dependencies are needed in order for it to run successfully. So this includes dependencies as well as tool itself. You have the inputs and the command that, depending on the parameters that are selected in the tool form, will eventually compile the command that the Galaxy will run on the server it's connected to at the moment. So it's just an elaborate translation from UI to the command line. And that's what it generally takes for a tool to be available in Galaxies. You have to provide such a wrapper. And again, that's what we're going to go through in a minute here. So I think I talked of that. We'll carry forward. So another element of that may be worth mentioning is, I said, so each Galaxy instance has its own set of tools. So if you launch your own, for example, or if you use one of the public ones, not every tool that has ever been wrapped for Galaxy is available on that Galaxy instance. So the way that these tools are distributed is through the Galaxy Toolshed, which is basically an app store for Galaxy. So once a tool has been packaged, you can publish it on GitHub. You can keep it locally. You can place it on your local file system or your local Galaxy instance, or you can publish it to this toolshed repository, so that any Galaxy instance can now install it through an automated process, and make it available to users of that Galaxy instance. And so some of the I guess, well, the distribution, I guess, is the main benefit that that one gets. The distribution happens for free, and there's a lot of infrastructure built around, like automatically installing latest versions on Galaxy servers that have a given tool installed, making sure that tools are tested regularly, so bit rot is minimized, and that's, I guess, the kind of upside to adding your package to the toolshed itself once it's available as a Galaxy tool. And you can browse, except there's about 10,000 or so tools currently available in the Galaxy universe. So that's URL on the bottom right is the URL where you can browse what all is available. So we'll go through this. What the sort of process is of getting a tool in the toolshed, but it starts off by creating this XML wrapper and then creating a descriptive file called shed.yaml. So that tells toolshed, the toolshed, how to publish it, and then there's an SDK that helps us get through this process. There's also this repository called short IUC, or Intergalactic Utility Commission, which I think in many ways maps to the Bioconductor review and release process for packages. Just this one is for the Galaxy tools. So it's a group of volunteers that have sort of codified best practices of wrapping Galaxy tools. And there's a repository that contains a bunch of tools that went through this process. And these tools, once you go through the process, they are sort of community maintained. They get automatically tested on a regular basis. And containers for those tools get automatically built and hosted so that Galaxy servers can easily consume them. And anybody's welcome to contribute to this. It's just there's a process and a PR review process that one has to go through in order for a tool to be accepted into this. It's an open repo on GitHub. And yeah. And so that's the background. Thought we would run through the process of what it takes to wrap one of the Bioconductor packages for use with Galaxy and see how that would work. So kind of zeroed in on this package called Complex Heat Map, and we'll use the Galaxy's SDK called Planemo to help us go through this process. So if you want to follow along, let's see, we're running kind of late on time, maybe. So if you have questions during the process, we'll try to answer. But if you want to do this afterwards, feel free to reach out to Tyler or me, and we'll help out at that point. But yeah, the URL here, I'll put it in Zoom chat in case anybody wants to follow along. All right, so I have that open here. I'll just follow along myself. So we have this, so we have to have the Planemo installed, which is just a simple command, and which I already have. But share this as well. So my terminal. So we'll clone this repo. This is just a blank tools repo. There's a template as described there that kind of bootstraps the process. For any tool, you can put a bunch of tools in the same repo. Right, it has a just kind of a standard layout for what one would want to establish before wrapping the tools. And this is where our sort of SDK bit comes in. I'll open up an IDE so we create a directory where we want to put our tool, and then do this planemo init command that says what the ID or the name of the tool we want to use, provides a description of it. This is where we can specify any number of requirements. In this case, this particular version of the complex heat map container already exists, so it sort of simplifies that process, and then specifies inputs and outputs. We can edit this later, but or we will edit this later. But basically, this will create us a skeleton of a Galaxy wrapper. So
yeah, the tool in it is something you can type everything you do it manually. You can just make the XML file yourself. This just speeds it up a little bit and saves you a bit of that boilerplate at the very start.
So yeah, we created that repository. I mean the directory, and it created this skeleton XML, right? So we can see the ID. It's got that requirement listed in here, and then it left these as blanks for the time being. Well, specified inputs and outputs to some degree, but so that's all it technically takes. So we can now do a planemo serve. Command, which will start up Galaxy in the current directory and show that tool to us in the Galaxy's interface on a local machine. So it's a great sort of interactive development convenience.
Yeah, basically, the Planemo serve is using a cache version of Galaxy that's usually stored in wherever Planemo is saved. Although you can specify a different path, and then it will start up a local instance of Galaxy and then install into that instance whatever tool XML to the directory you pointed at, and it lets you view what your tool XML would look like to a user who's using it on a Galaxy instance and give you full interactivity. So you can still upload data, you can run your tool in this interactive mode. And then it will allow for hot reloading. So as you change that XML, if you like add a help description for something, just reload the browser and it will show you what it would look like live immediately. So it allows for like kind of like that rapid look of what it would actually look like to the end user while you're running it to make sure it's working correctly.
Server running on that port, so it didn't. Forgot to turn that off. Just take a second. Go back to the browser. Right, so we'll do that. So while this is starting up, as we saw in the slides, Galaxy will ultimately create a command line that it needs to run on the server, right? And so it needs a single executable that it can invoke. And so in the case of ARC or Bioconductor packages in R, it needs that executable needs to be an R script that our wrapper can invoke. So this is the that I guess additional interface. So in this case, it just parses the arguments and calls the package. So we need to create that script that will allow Galaxy to invoke the package. So that's our sort of command prompt or command tag. Let's see if this thing started up in the meantime. All right, so we have our Galaxy running. This is running locally, and you see that complex heat map tool that we created a draft of. And you can load it up as a tool form. And so you'll see as we update the wrapper, the interface will change. So like I said, we need that R script. So we'll just create a new file with the what was the name that used? So I have to paste the contents of that script, and now we'll have to go back here and fill out the command that Galaxy will invoke, which means invoking this R script. So to minimize typing, that's what that's going to look like. So it uses R script for our current tool directory and calls the script providing the input and output. So put that in here. Follow along with these inputs and outputs. That said, it created a couple in here. We can see it just has the matrix CSV that we can supply in a PDF output. We're adding one more as the title of our plot. And so when we save this, this here in a second when it reloads, we'll see that our tool form has changed to support the heat map option that was added. So again, you can sort of interactively go back and forth.
I'll also say one other thing, Enis, if you go back to the command on VS Code. So in there, basically it's just invoking that R script we wrote, essentially, and then processing it. There's one kind of Galaxy specific thing. There's a couple like XML special variables that are natively defined to Galaxy. The two you would often hit are that like underscore tool directory one. And basically it's just a reference helper to point to the tools directory itself for easier um, like accessing of where things are files relatively. And then oftentimes another one that you'll commonly see is something like Galaxy slots, which is basically used to specify the number of cores available to a job if like tools multi-threaded. By default, users aren't allowed to select how many cores are they're allowed to use because everyone has selected very high number repeatedly. That's usually chosen by the admin on the back end. They'll specify how many cores should be given for a job, and that's changes. It's dynamic based on like data input sizes and a couple other things, but it's defined back by them. So something like a Galaxy slots we're able to see there. So if there's ever like a threads command, you'll see like Galaxy slots passed in. And you can also, as like the XML author, like write in a default for how many cores you think should be used in. The admin will probably override it. That's always an option. So you'll kind of see those two. Another thing I'll say is often with R, you'll need that file to kind of like parse and give you your real command. But you can use, I believe, the arg parse R package or some of the other built-in R packages for parsing arguments to make it simpler.
Well, maybe I'll just rush a little bit through this. So we got about 15 minutes left. Or maybe I just, I don't know, or well, maybe I'll just talk through this as opposed to doing it. In case there's we want to have a few minutes at the end to kind of talk through some options. So yeah, to complete the tool, you'd want to add some small, simple test data. So to make sure that the tool continues to run. So provide a simple TSV file in this case. And then in the wrapper indicate how that tool is to be tested. And add help text that will show up in the tool form on the down here in the help, and then also the citations for author of the original package that are listed, and that too gets listed in here. And a neat feature is that you can create a if you run a history, you ran a number, 10, 20, 50 tools, whatever, in a given history, you can say, what was it? Export tool references. It'll give you a BibTeX of all the tools the citations from all the tools that were used in a given history that you can then include in your paper. And then once the sort of the wrapper is done, back to Planemo, there's a number of sort of convenience functions that format the file according to those IUC requirements that we were mentioning. It'll lint it. It'll run the test automatically. So this runs, in this case, with this containers flag, it will run everything in containers. On your local machine, you'll get a test or fail or a pass note to build confidence in your wrapping before you create a pull request to either IUC or publish it to the toolshed. And then the toolshed process, there's about half a dozen more steps where you create a repository on the toolshed for your tool and publish it. And again, every time you lint, you go through the testing process. First time you create a repository, and after that you just update it, as you've updated the version of your wrapper and or the tool package. So does it happen in the toolshed, and so people can install any published version as they wish or want to. So if you create a workflow later that uses a specific version, anybody wants to use it in their local Galaxy instance can install that specific version that's been published.
I'll also say if you're pushing to the IUC GitHub repo, that like heavily curated one, you don't need to do any of the toolshed steps because that's all handled by the continuous integration on their end. So as long as you just do the tool wrapper and do the PR request, all the toolshed stuff is handled automatically for you. So it's a nice time saver if you go to the way. It's a little harder on the testing. They're a little more strict on formatting and ensuring best practices, but you don't have to do any of the toolshed. That's all handled.
So if I could ask Kevin's question, because it sounds like he might not be able to use his mic. It sounds like he's interested in trying to figure out like how to manage string. Oh, Kevin,
You,
can you take this?
yeah,
Sorry.
you want me to jump in? I managed to distract my daughter with like some cartoons. So yeah, it's a bit of a personal story on this one. I've started a Biofair Pathfinder project a couple months ago, and the first thing I started with was basically the intention is to write a Galaxy tutorial. So there's two Galaxy tutorial, one for single-cell analysis, one with Seurat, one with Scampi. And it felt natural to add one showcasing Bioconductor as an alternative workflow. But one of the friction point of the issue I've faced is basically I immediately felt the need to start rewrapping some tool that already exist in the IUC tools because they were wrapped 7 years ago. The arguments were not really there, and some of them were actually wrapped. It was fairly package centric, I would say. And so they're not necessarily naturally flowing together the way an R script would flow top to bottom, because in Galaxy you need to the currency between the steps are files, right? So some steps output an R data file, others an RDS, others a Loom experiment. And so I'm facing the challenge of basically if I want to plug them together, I keep the existing workflow and I add a bunch of conversion steps in the middle, or I actually spend some time, like you said, the process, contacting the maintainers of the existing wrappers and seeing whether they can be converted. But some of them, the Skater package is a large suite of tools, which for one tool that I need converted, if I want to do it well, I will probably have to convert the whole toolbox to avoid breaking stuff. Do you have any comment on that? Maybe not personally me, but general rules about would-be contributors and these kind of pitfalls and what to expect?
I've also run into similar issues, I guess, with certain maintain tools. The latest one for me was like the card RGI tool, it's like an antibiotic resistance gene identifier tool that was maintained by the actual authors of the original tool card, but the Galaxy wrapper was a mess and hadn't been updated for years. And I had to rewrite it. I think that's kind of just a natural friction point. I can say usually for like the tool form design, there's often an emphasis on like isolated functionality a little bit. So it's like each individual tool becomes its like own like compartment. So if you like look at like the ScanPy tool suite, I know for single cell you'll see like there's not like one generic like large tool form. It's like, each individual step that we done is like broken apart, which becomes a little confusing to use sometimes, but it's often what is done. In terms of like updating it, as far as the tools available in IUC, and there's another repo called the Use Galaxy Tools, which is the same thing. It's just for tools that have test data above 1 MB, because the IUC doesn't allow it. So you'll see it in both often. Anyone can update it without talking to the previous maintainers. You can just do a PR against it with the new updates and go through the process. In terms of coordinating it, it's kind of a pain for single cell specifically. Galaxy has these like, I guess they're called like SIGs, like basically interest groups, and there's a big single cell interest group that does coordination and wrapping of the single cell tools. They've mostly been doing the ScanPy suite. I know for like the past 2 years, they had a much bigger emphasis on that, but they usually coordinate how to update all the single cell packages directly, and like distribute the work to like people to try and get it all updated. And they also have a big emphasis on like training and a lot of tutorials. Wendy Bacon used to be in charge of it. She's no longer as heavily involved, but I think Pavon and
Yeah,
I'm not sure what the
Pavan
rest
and
are.
Marisa
Yeah.
are the two so they're the two team members I have from the Galaxy side on the on the Pathfinder, and they've been very helpful. But I think I was kind of rushing a bit forward with like the tool development, and so I ended up basically writing alternative wrappers to the existing one, and that's when they surfaced the fact that you don't really want to read 10x counts. Sorry, in the same repository, right? So you don't want to
Yeah.
write two versions of the wrapper and have confuse the users with two different things.
No, that's also very true. Usually you just want the one source of truth. Um, I guess in the case of the workflow you're doing, is it the previous tools, just their output files? Are they just missing the um, corrected format requiring the transition in the middle? Or is it you trying to chain together like multiple steps on like the single cell experiment objects, like in a row
Yeah,
without having to do multiple tool runs?
I've got a few examples, but there is, for example, so one of them comes from the EBI, so they have their own GitHub repository, right, which is brought into the European server, and so they have a read 10x count. So this is from droplet utils. Great. So you've got your 10x files, you read them into the Bioconductor object, and then what I want to do is calculate QC metrics on that object. And unfortunately, the calculate QC metrics it doesn't work directly on the backconnector object, even though it's a backconnector function. The wrapper was written in a way that it actually wants the matrix in a text file. So it kind of goes back one step, or you have to re-extract the matrix that you've just loaded into backconnector object back out into a text file so that you can actually calculate the QC matrix. And that QC matrix also, so the QC matrix reads the text file and makes again a single cell experiment object, but this time in the Loom format, while the first one was doing in an R data format. So, it's kind of
Yeah, they're doing
wrappers.
format conversions within wrappers that don't make sense.
Yeah, which I'm sure when the individual wrapping tools were written, it made sense. But it looks like they were written, well, it looks like they were written separately, and so not designed to work together. So individually they do sort of their job, but not in the way you do it in a, in an R workflow. So if you try to emulate an R session, you just can't do it that way. If that makes sense.
Yeah, it's not in a natural way anyway for someone who's going through it if you have to do data conversions between multiple
Um,
objects.
yeah, and
So
I think
if I
there's some
could try
best.
and
Oh yeah, go ahead.
I was going to say if I could try and get us back on track because we're close to the hour and other people might have better questions. But this is a sort of a common problem in terms of like the way that some of us who build tools think about programmatic units aren't necessarily the same way that like users like especially users like far in the future may think about those programmatic units. And I was hoping maybe this is something we could get insight on from the Galaxy community about how to write guidance maybe within Bioconductor for how to build these R scripts. Like because as Kevin points out, right, like you know, Galaxy users aren't going to want an R data file at the end of one of these scripts, right? They're gonna want something. They're gonna want like their tree or their multiple sequence alignment or their matrix, and how we choose to create verbiage for this stuff is going to matter in the long term. So like if you guys have success with like advising other people about that, I think we'd be interested in that.
I would need to check what was done with ScanPy, but I know they um, worked to standardize the and data object that was used and how it was transferred across the different tool sets to be compatible. And I know often what was done with some other tools is Galaxy allows for there's tons of data types and you can write and add your own ones if you want for anything that's custom, but very often you can expose to like the user's history any intermediate or output files you want. So often if something needs to be moved around, you could expose both like the and data object as well as whatever plot or whatever information come out. So like the output of the tool would be the one thing the user wants, and like the intermediate input file that can go into the next one, that can be more easily consumed. But maybe I don't know if you would know this either. I think some of it is just because of the like we should probably do better guidance too. Some of it's just because of the distributed nature of how tool wrapping is, because it's done by individual people, if there are standards. Through the IUC, I think sometimes you just run into that. Like,
I mean, I'll just chime in with something. I don't have personal experience with this particular problem, but I see what you're saying. And it's a dynamic environment. Somebody did it for their own needs, or without an end goal in mind per se, or a different end goal in mind. So it's ultimately just software. So if it doesn't work today, it doesn't mean it doesn't have to work tomorrow. And so contributions and discussion are very welcome. I think people are open to it, hence, versions, and also that you can kind of zero in on what works in your particular scenario. And I mean, from what I'm aware of, at least, sort of close interactions with the Bioconductor and art communities have been kind of slow or not super developed. So maybe we're just missing some of the elements that you guys can contribute, bring in. And so those guidelines that exist today can also be modified to better suit and support the use cases and scenarios as are more native in the R world.
I'll just jump there. So I think we're at time as well. So I think on a positive note, I mean, my Pathfinder is still running for another 10 months. And one of the things I would like out of it is actually exactly the kind of guidance we're talking about. So I don't know if, I mean, if it's you two I should be talking with, or if you can redirect me to someone who maybe has the bandwidth to interact with me so that I show them like the use case I'm facing. And I'm happy to like take on some of the work, right? It's like 40% of my time for the next 10 months that I can invest in that. And yeah, so where should this guidance would go? So some of it, it's probably coming on the Bioconductor side, but written collaboration with the Galaxy side, but who in Galaxy has sort of the say in that? So I don't want to go
Yeah.
over it by
So
too much, but if you're happy to stay in touch after the call, yeah. Enis?
So yeah, I mean, I know you're coming to GCC, but anybody else that's interested, it's coming up in a few weeks. So I think that would be a great place to continue this conversation because most people that I don't know that anybody has a say per se, but it's a communal sort of decision-making process. But it can certainly be influenced. So I think that's a great venue, great place, opportunity to kind of get some level of better understanding, traction, and uh, progress. Um, I think that's the.
I think
Otherwise, creating an issue on GitHub, that's always the approach that I hear. Saying start a conversation there. Sometimes it's just difficult to get enough traction to change the process substantially, all online. And so maybe starting with a GitHub issue describing the process and then circling back to it in a few weeks when we meet in at GCC.
I think the person who'd have the most impact for being able to change it within like the IUC and get it propagated would probably be Bjorn. I guess last name wrong. Grunine. He's often, at least when I've done things on the IUC, he's always who I go to for help and get permission for things and changes. Um, but the other thing is I think that could be both at the conference, but I think there's also a IUC/IWC monthly meeting. But something that could be addressed because I think more so than just this use case, it's probably worth it to have better guidance on how data should be able to be consumed and stored across tools. Because I don't think currently in the IC or IUC there's like directions for that. There's directions for how things should be wrapped, how syntax works, how testing is done, but I don't think there's anything for outputs, like how it's stored.
Can I just ask one quick question? I think maybe we can wrap this up afterwards, but we can keep going if you want. But what is your so how do the containers on the back end are like anything that's built on a on Bioconductor, you're targeting it with that like biocontainers flag, and that is just pulling the sort of standard Bioconductor container that we offer, or um, what sort of support is there for people who want to bring their own containers if that's a thing that they want to do?
You can use your own Docker container image that you write and just have it reference that directly.
Okay.
And when you're, I also say this, when you're wrapping and building the tool, you can, I think the command's Docker shell from Polimo, but it gives you the interactive shell to work exactly inside the container within Galaxy and access what it's doing and seeing how it's worked. But it's full support to bring any of your own Docker containers, or I believe Singularity containers as well.
Okay. And then like because I've unfortunately built some monstrous containers in my time. Is there a limit on those sizes, or is that
I I don't think so. I think that depends on the admin if they want to
okay?
install, but I don't think there's a limit on like install sizes or what can be submitted. I think it's
Uh,
all fair game.
if a conda package exists for a given package or tool, then it will be automatically built as a buy container and hosted. If so, and then there's no, so in that case, it'll just be like a single requirement, as we see here. It's a package, but there is a buy container package that corresponds to this particular version, even though the latest version I think is 2.28. But that doesn't exist. In that case, Galaxy will attempt to either build a container or create what's called a multi container. So it'll stack multiple layers of different containers that have their requirements specified to create a virtual one. So again, the principle that a container should contain the sort of a minimal unit, usable unit, kind of holds, and a lot of that is sort of tried to be implemented in an automated fashion on the back. But yeah, I mean, at the end of the day, you can just say here, type Docker and provide your Docker image ID here, and it will just get pulled. It just take a little while if it's big for it to start running.
All right. Well, we're 5 minutes past the hour, so um, I am going to stop the recording for a second, and then I guess if people have more questions after this, we can keep going with them. But thank you everybody for coming by. This was a really enjoyable talk. I hope other people really liked it, and it was really informative. So the recording will be ending now.